Right, I've powered up my transmitter, I've selected the right model, and I've powered up the hexacopter. Ignore the fact I got the blades on. I've already set this up, so there's no worries, but I can't emphasize enough, you shouldn't have the blades on. I'm going to plug it in to my USB port. I'm going to load this software. Now it's the Lite, so I'm going to use the Lite configurator tool. So it should go straight in. There we go. Sometimes you have a menu where you say skip. Right, now I don't know whether you can see, I've got all the channels, I've got an overview of everything that's set up. So quite simply, the first thing you must do is you'll go into the basic setting and tell it you are doing a hexacopter. Right, as you can see, motor 1, 2, 3, 4, 5, 6 and their rotations are displayed in that graphic. You have to make sure that the motors are plugged in that order. So motor 1, the front right, is plugged into M1 and so forth all the way round. If not, you will see it flip over and do the funky chicken, and you will watch your pride and joy smash itself to pieces before you can turn the power off and disarm it. So be very, very careful. It's quite amusing to others, but not to you when you spent all that money. So make sure that you have the props and everything spinning in the right rotation. So check the motors before you do it if you have to alter ESCs, etc. Fortunately, I had this flying up with a NAZA setup, so the props and ESCs were already configured correctly, but the motor positions were different to the NAZA. So M1 motor 1 is not there on the NAZA board. I think it was back here. So if you've marked in 1, 2, 3, 4 to match the NAZA, it won't match NAZA. So be mindful of that, because that was a bit worrying. So there's a few settings. I'll go through them quickly. The mounting, this is where you put some figures in, some measurements from where your GPS, the GPS puck, is in relation to the main receiver on your craft. So a couple of centimeters here, a couple of centimeters there, just so that the GPS knows where it is in relation to it. You go into the RC. Now this is where you're going to go. I've gone PPM, so I've selected PPM. However, on PPM, channel 1 is aileron, channel 2 is elevator, channel 3 is throttle. It's not NAZA and it's not JR, which we normally use, where throttle is 1. So be mindful of that. You have to configure it that way. You see the throttle goes up. Aileron, elevator, etc. Now another thing, I did have a problem where I couldn't get it to arm. Now when I push the elevator stick upwards, it goes to the right. Now that's a little bit different to the NAZA setup, because normally when you pull the stick back, I believe it goes the other way around. So with this, you have to make sure that you move the aileron right, it goes right. You move the aileron stick left, it goes left. When you pull the elevator down, it goes down at the range, and when you put the elevator up, it goes up the range. There's a lot of people get that wrong, and if you notice, I've got it reversed there, and by reversing it, I actually reversed it in my transmitter to get it right. So you have to get that right. Obviously the throttle, the ranges, the endpoints, you need to get them through. There's also the rudder left, right. So everything will work conventionally. Now you also see at the bottom there's some switches. These switches here, positions here. Now I've got my flight control switch. So in GPS mode, it is illuminated in the GPS option. In what I got called acro is selected the attitude mode. And that is basically flying around without GPS lock, but you have stabilization, so you can fly it around pretty much like horizon mode on the NASA's. You can, do what you want, but it's not, if you let go of the sticks, it's not going to stay there like GPS. And then you have manual, so that's full manual mode. So That's quite simple. There's lots of YouTube videos saying how to set up your Tyrannus. I'm not going to cover that in this. It'll drive you nuts. Anyway, going back to it. There's a gain. I've allocated a switch. In fact, I've allocated one of the knobs on my controllers. If I turn the knob up and down, you can see that the gain changes. I'm not letting it adjust any gain on the yaw. I kept that the same. I just adjust the gain on the roll and pitch. So that's basically like your PID controls. If you want it more lively, then turn it down. If you want it more locked in, turn it up. Or vice versa. You can try it when you're flying. So just set it to a knob, set it where you like it. I've set 100 in the middle. Some people set different settings. See what you're happy with. Again, there's lots of videos. When you go into the advanced mode, you'll then see that there's some options. Now, we've seen lots of videos about let me explain. If you set it to intelligent mode, it looks at, if you read the instructions on the side, you can arm it. When you arm it, the prop starts spinning. So be mindful of that. When you put them into the armed mode, the props will start spinning and you will panic. So it's better, because these are high-speed motors. They're 2300 kV motors. I didn't know what the implications would be, so I turned it down near the low side. It could go to the low, so the prop starts spinning, but it's not trying to take off. So there's an intelligent or immediate. The immediate is in any control mode. Once motors start and the throttle stick is over 10%, the motors will stop. The throttle stick is over 10%. Intermediately, when the throttle stick is back under 10%, in intelligent mode. Right. Fail safe. When it loses signal, what does the craft do? What it does, you select go home and land. It turns around and comes back home. So you can have it just to land. So whenever it loses signal, it just drops down and land. Why would you want that? You know, if you're flying around somewhere and you think, right, I've lost signal, just land where I've lost you, then, you know, it's not so clever. So the go home and land means it turns around. I should imagine this landing one might be a difficult if there's obstacles between you and where it's got to fly back, and it could fly into the obstacles, perhaps. I don't know. But anyway, so go home and land in. IOC. Some people like to fly line of sight. If you fly in line of sight and you get too far and you can't see where you're going, you can't see where the front and the back and the LEDs are not bright enough, what you can do, you can flick that switch, and basically the back stick means it's coming back towards you. There's two different modes. There's a home lock and there's the course lock. And basically what they're saying is the home lock, it means when you pull the stick back, it'll come back towards you. The course lock means if you set it on a direction, then it will carry on in that direction. If you pull the stick back, it will stay in that attitude and just come back and forth, basically like north-south compass heading. It won't come back towards the home position. It will go back and forth. If you switch it into that mode when it's pointing away from you, then the sticks will always mean whatever rotation. If you're using the camera, you could be spinning the quadcopter around with the yaw, but the forward will make it go away from you and whatever. But anyway, you can read up about that. And then there's the off. Oh, inactivity alarm. Thank you, radio. Right, there's also gimbal and there's voltage. Now, as you can see, I've turned it off. There is voltage alarms, and there is situations where when you get low voltage, it will go into protection and will descend. So you see lots of videos where people are running to save their quadcopters, their phantoms and the like, because it's got low battery, and then it stopped control and said, right, I'm now landing because you've run me down to an unsafe level and I can't fly anymore, so I'm landing. And quite often that means it's in the sea, in the lake, in the ponds, and you see people running trying to retrieve them. That is where you need to turn it off. I'd rather come back with a knackered battery than watch it drop into the water. When my OSD tells me the battery's low, I'll be turning on and coming back anyway. But if I don't make it, I don't want it stopping to losing control. I'd rather watch it sink to the ground and try and do a safe landing. But anyway, that's me. That's what a lot of us do. So, and that's about it really. There's a check IMU status. That's to check the processor's working and like reset the gyros. But upgrade, latest firmware is firmware 1, and that's what's in there. So nothing to do there. There's an information, current version, no upgrades. I've actually signed in. I had to make an account for it. Now it's saying that my serial number is that. Copy. Import your serial number. You can try 30 times. Command V. Enter. Write serial number succeed. Okay. Don't know what that did, but I did it. Probably going to pay for it in the future. Anyway, so it's already uploaded in there anyway. So yeah, so just to give you an input, all those channels were programmed into my my Taranis to make me do that. Now there was a little oddity, which will be quite exciting for you, because when I went back to RC, there is, I don't know whether you can see it down there, there's a fail-safe mode. What is the fail-safe? When you want to switch it to return to launch. Return to launch. Bring it home. When you've lost video and you're in panic mode, you can flick that switch and it returns to launch. I had to do, there was a little software thing where I had to put a little adjuster set in the program to make it shift it by that much. So I had to affect that channel and like put a little add-on, but that's in. I can show you that, or you can Google it and they tell you how to do it. So the rest of the other channels were just changing endpoints. That fail-safe was a slightly different procedure. So if anybody's stuck, let me know and I can show them on my Taranis how I actually programmed that. So everything else was pretty straightforward. Just in endpoints, midpoints, get everything right. So when you throw the switches, they go into the right positions. You just adjust endpoints and trims till you get it to be under there. Nothing complicated, nothing to worry about. Just identify all the channels and set them onto your switches as you require. Can be a little bit tricky at times if you're not familiar with all the programming of your Taranis, but there's lots of videos out there. So yeah, that's a bit of a tour from it. I hope you get something out of this. Flies, I've given it a test flight, but I am going to do a video of it actually flying. It does fly very nice, very stable, seems quite locked on. It is more sedate. It's not like flying it on a NAZA configuration where you've got, you know, permanent connection, you're flying, wherever you put it, it goes. It's more of a fly-by-wire experience. When you're in GPS, you release the sticks where you want it to stop, the thing drifts away and then comes back to that last position as long as you don't touch the switches. I had a habit, I kept on pulling back, saying, no, you've gone too far, pull back, trying to get it to get into a position, and every time I left it, it started drifting. But what it was me being impatient. If I just left the sticks alone for a couple of seconds, it recovers, recognizes where it should be, and then goes back to it. So you have to give it time to control. So yeah, I'm going to test it out, so there'll be some videos. So it's a lovely bit of kit. I can't wait to fly around. As you can see, there's lots of lights, lots of nonsense. I have OSD on it. I've done the Taro OSD. I plan to do a video of it at some point later, and that is a cheap OSD. However, there are newer and better things coming on the market, and I'm hoping, fingers crossed, to have a new OSD device that will work with my NASA board. So a friend of mine, he develops these things, so I'm hoping he's gonna send me one to give a trial of. So, and do a little video of how to set it up. So yeah, lots to look forward to. Hope you enjoyed this and got something from it. I know it's a long video, but sorry about that. It's not a short, and I don't like doing part 1, part 2, part 3. You can fast forward through and get to all the relevant bits. Hi. Somebody said to me the other day, they said, oh, I like your videos, but you must spend all the time in the shed. Yeah. And